Good morning, my dear students. In this particular video presentation, again, we will discuss some more problems meant for students of class 12 or CBSE, which are very often tested in the board. The first problem meant for today, it is from continuity. The problem goes like this. See here, f of x is equal to, you are defined 1 minus cos kx by x sin x if x not equal to 0, and it is half if x equal to 0 is continuous or x equal to 0. Find the value of k. Just listen carefully. F of x equal to, defined this way, is continuous x equal to 0. Then find the value of k. That is the question given to you. I'll move on to the answer directly. Okay, f of x equal to so and so. This is given. You have to write this point first, which implies limit x tends to 0 of f of x is equal to f of 0, which will imply you limit x tends to 0 of 1 minus cos kx by x into sin x is equal to, this value is at 0, the function value is half. Now this is reduced to limit x tends to 0 of 1 minus cos 2 into kx by 2 by x square into 1 by sin x by x. I will multiply and divide by x in the denominator. I need it, therefore I do. Here I will very well write this as 2 sin square kx by 2 by x square into 1 by limit x tends to 0 of sin x by x is equal to half. I'll take limit for this separately, and here the reason is 1 minus cos 2a is 2 sin square a. That is the formula to be followed. Therefore, what I will do is I'll take this 2 outside. Limit kx by 2 tends to 0 of sin kx by 2 by kx by 2 the whole square into k square by 4. Multiply and divide by k square by 4. This limit x tends to 0, sin x by x will be always 1. Here just multiply and divide by k square by 4. This can be written as sin kx by 2 by kx by 2 the whole square. But whenever x tends 0, kx by 2 will also tend to 0. This is 2 into 1 square into k square by 4 will be is equal to 1 by 2, which implies k square by 2 is equal to half, implies k square equal to 1, implies k is plus or minus 1. K can take plus or minus 1. That's the meaning. K can take any real value. Both the values 1 and minus 1. Let me repeat the whole process. F of x equals so and so defined is continuous x equal to 0. The real meaning of a function continuous at a particular point is the limiting value is equal to the function value. Now for limit x is 0, f of x equal to f of 0. Limit x is 0, 1 minus cos kx x sin x equal to half. Whenever x not equal to 0, this is the definition. Tending to 0 means it is closer and closer to 0, but not exactly is equal to 0. Remember carefully. Now I'll multiply and divide by x in the denominator. I'll apply limit for this separately. This limit becomes 1. And of course here I'll use the formula 1 minus cos 2a is 2 sin square a. Now for here multiply and divide by k square by 4. Whenever x tends 0, kx by 2 will tend to 0. This limit will become 1 square. 2 into k square by 4 gets reduced to k square by 2, which is equal to half. Now for k square is 1. Now for k becomes plus or minus 1. K happens to be plus or minus 1. It's not at all a difficult task. Understand the logic behind this, but you should keep on writing the limit etc. till the case where you apply the limit. Till the place where you apply the limit, you should keep on writing limit x to 0 or whatever it may be, what is given in the question. Do that sincerely. It's as equal as having the ticket till you get on from the train. Used to have the ticket till you get on from the train. Nowadays you are having everything in your mobile. It's a different fact. But still, when you are going to possess a ticket, you are supposed to possess it till you get on from the train. Similarly, you are supposed to keep on writing x tends 0 or x tends to a, whatever is given, till you apply the limiting value for that particular function. Second question goes like this. Okay, you are given f of x equal to root of 1 plus kx minus root of 1 minus kx by x if minus 1 less than or equal to x less than 0. Then this is 2x plus 1 by x minus 1 if 0 less than or equal to x less than 1 is continuous at x equal to 0. Find the value of k. I am not going to write the question. This is my function between minus 1 and 0, inclusive minus and exclusive 0. This is the definition. Inclusive 0, exclusive 1, between 0 and 1, this is the definition. This is continuous x equal to 0. Find the value of k. That's the condition given. I start with the answer. Is continuous at x equal to 0 given. Remember carefully, the very idea or difference between the previous sum and the present sum is, I won't write the left hand limit, right hand limit. I would not have written, you might have seen there. I won't write LHL or RHL there because below 0 as well as above 0 the function value is the same. But here it is different. Therefore, what I will do here is LHL at x equal to 0 is equal to RHL at x equal to 0 is equal to f of 0, which implies left hand limit. LHL means left hand limit. X tends to 0 minus f of x is equal to limit x tends to 0 plus f of x will be is equal to f of 0 is nothing but 1 by minus 1, which is minus 1. 0 plus 1 by 0 minus 1, which is minus 1, which will imply you limit x tends to 0 minus of root of 1 plus kx minus root of 1 minus kx by x is equal to, here limit x tends to 0 plus of 2x plus 1 by x minus 1. Above 0, definition of the function is defined like this, which will imply you limit x tends to 0 minus, if you apply directly the limit is of the form 0 by 0, it's not possible, it's not at all defined. Okay, now for what I should do is, I should multiply and divide by root of 1 plus kx plus root of 1 minus kx. Do this process. Root of 1 plus kx plus root of 1 minus kx. Multiply and divide by this quantity. It is as equal as conjugation you might have done in complex numbers. Similar way you do here. Here of course this is 1 by minus 1 is equal to minus 1. Now therefore this is anyway it will get reduced to x tends to 0 minus of, in the numerator I will be using the formula of a plus b into a minus b, which is 1 plus kx minus 1 minus kx by x into root of 1 plus kx plus root of 1 minus kx. Just listen carefully. Is equal to minus 1. This will automatic 1 anyway gets cancelled. A square minus b square, a plus b into a minus b, a square minus b, the root will go off everywhere. Limit x tends to 0 minus of 2kx by x into root of 1 plus kx plus root of 1 minus kx will be is equal to minus 1. This x will get cancelled. Let me apply limit now. 2k by 1 plus 1 is equal to minus 1. 2k by 2 is equal to minus 1 implies k is equal to minus 1. Therefore, take down and write value of k should be minus 1 for the given function to be continuous x equal to 0. I repeat, this is a function defined which is continuous x equal to 0. Therefore, the limiting value equal to function value I am supposed to write. But below 0, the definition of function is something else. Above 0, it's something else. Therefore, I have to write left hand limit, right hand limit. LHL means left hand limit. Limit x in 0 minus f of x. Limit x in 0 plus f of x equal to function values 0 plus 1 by 0 minus 1, which is minus 1. Here, this is root of 1 plus kx minus root of 1 minus kx by x. Here, it is 0 plus 1 by 0. It is anyway equal to minus 1. It's enough to write minus 1 once. It's repeated anyway. Multiply and divide by root of 1 plus kx plus root of 1 minus kx. In the numerator, I will be using a plus b into a minus, multiply and divide by this quantity anyway. And here, use a plus b into a minus b, a square minus b square equal to a square minus b square formula. 1 plus kx minus 1 minus kx, 1 gets cancelled. Kx plus kx again 2kx, this x gets cancelled. Now apply the limit. 1 plus 0, root 1 is 1. This becomes 2. 2 gets cancelled. For value of k should be minus 1. For the given function to be continuous, x equal to 0. For the given function to be continuous, x equal to 0. Are you following? It's not at all a difficult task. Okay, next one, I'll do it faster. I'm making it for maximum 15 minutes every video. I'll add up one more problem. Okay, I'll just add one more problem. It's an easy thing. Okay, it's an easy one. A is equal to set of integers. A is equal to set of integers. Then the relation R on A is such that A or B is equal to if and only if mod A minus B is divisible by 150. Divisible by 150. And of course, show that R is an equivalence relation. And also find elements to which 0 or is related. 0 is related. I repeat, A equal to set of integers. I mean to prove A or B if and only mod A minus B divisible by 150. Then show that it's an equivalence relation. It's not a difficult task. Just see here, mod A minus A is 0 is divisible by 150. Divisible by 150. 0 is divisible by every number except 0. Therefore, A comma A element of R for every A element of capital A. This is the definition of relation to be reflexive. Let A comma B element of R, which implies mod A minus B is divisible by 150. Now think about mod B minus A. Mod of minus of A minus B. I have no idea whether I have done this on one of the videos. I am not very sure. Which is also divisible by 150. Mod B minus is the same as mod A minus A. Therefore, B comma A element of R. Therefore, A comma B or B element of R implies reverse way. B comma A element of R for any two A comma B element of A. Therefore, this is the real meaning of R is symmetric. R is symmetric. Then let A comma B, B comma C element of R. Mod A minus B, mod B minus C or divisible by 150, which implies mod A minus B is equal to 150K, mod B minus C is 150L, K comma L element of N. Those are positive numbers, therefore I take it as natural numbers. Now remove modulus plus or minus 150K, remove modulus plus or minus 150L. Now add the results. A minus B plus B minus C, B minus C is equal to plus or minus 150 into K plus L. Here B gets cancelled. A minus C or mod A minus C is 150 into K plus L, which will imply you A comma C element of R. Therefore, here I mean to say R is transitive. Therefore, you can even take down and write R is reflexive symmetric transitive. Therefore, R is an equivalence relation. Take down and write, dead right, R is an equivalence relation. Okay, the elements to which 0 is related, that's one you are supposed to find out anyway. It's as equal as equivalence class. The word equivalence class may not be used in our examination, but the question may be given as find the elements in A to which 0 will be related. Now what I will do is, I'll just write 0 in the middle. Keep on adding 150 here. 150, here of course 300, etc. Here minus 150, minus 300, etc. These are the elements. Or you can even write 0 plus or minus 150 plus or minus 300, etc. Which are the elements to which 0 is related. We can just check mod 0 minus 0, this will be 150. Mod, 0 minus 150, which is 150, this will be 150. Mod 0 minus 300, this will be 150. Mod 0 minus or minus 150, plus 150. 0 minus or minus 300, or everywhere. If it is related to 1, if you are given, write 1, keep on adding 1 towards the right. 151, then 301 and so on. Similarly here subtract 150. Here minus 149. 0 minus 150 is minus 149. Then minus, just check what the answer will be, etc, etc, etc. 349, whatever it may be, you just check. Okay, check what the subtractions are going to be. There again, mod 1 minus 1 is 0, this will be 150. Mod 1 minus you are adding mod 1 minus 151 here, sorry, 151, sorry, okay, 151, which is 150, mod 1 minus 150 or plus 150, whatever it will be, just check. You can very well write, you are putting modulus, therefore 0 minus 151 you can say, or 151 minus 0, either way you can write, doesn't matter. Similarly here, 1 minus 301 is divisible by 150 and so on. Similarly for the negative values also, therefore it's easier way to remember, and this can be replaced by any number here. Okay, divisible by 100, divisible by 1000, divisible by 200. The same method is being carried over, and to find the point to which a particular element is related, write that element, keep on adding 150 divisible by 150, keep on adding 200 if divisible by 200, subtract 200 towards the left, subtract something like that. It's easier for you to get a final answer easily. Okay, this is also easier if you remember the method. Thank you students for patient watching. I'll check as usual, then I'll upload.